All right, back streets back. All right, okay. Atomic mass. The atomic mass of calcium is Ca 40.1. Now you may ask yourself, why didn't I put 42? Because that's a mass number. That's not the atomic mass. If I converted this and rounded it to 40, that would be a mass number. This is a mass number. Atomic number for calcium is 20. Remember, A equals P equals E in a neutral atom. Since they didn't tell me anything about electrons, I have to assume this is a neutral atom. So A equals P equals E. And the number of neutrons. So I have a mass number of 42 minus 20 protons equals 22 neutrons. No, it is not an ion. It is an isotope. How do I know it's an isotope? Because the atomic mass on the periodic table is 40.1, and they've given me atomic mass different than that. The thing on the periodic table, if I rounded that into a mass number, would be 40. 40 minus 20 would be 20 neutrons. This has a different number of neutrons than the thing on the periodic table. So this is an isotope. It is not an ion. It is an isotope. I got to clean off my periodic table. It's going to drive me nuts having all this stuff on here. Sorry guys, sorry for the delay, but just having stuff circled is driving me crazy. A little OCD about that. I'm going to leave the S, P, D, and F on there because I think you should learn that. Okay, aluminum, atomic mass, aluminum, 27.0. Atomic number, 13. Number of protons, 13. Number of electrons, I have a different number of electrons. This is an ion. How do I know? It has 11 electrons and 13 protons. It has 2 more protons than it has electrons, which it should have 10. Interesting. This should have 10 electrons. This should be plus 3 charged. Mr. Irwin made a mistake. Don't hold my feet to the fire over this. Okay, number of neutrons, 27 minus 13 is 14. Okay. Iodine. Iodine's atomic mass is 126.9. On the periodic table, 126.9. Atomic number for iodine is 53. Number of protons is 53. Number of neutrons. So if I round this to 127, and I subtract 53, I get 74 neutrons. Number of electrons is 53. And it is no, it is none of the above. Yes. Okay, atomic number 17. What is it? Well, all I have to do is go here and look, and it is chlorine. Oops, chlorine. Its atomic mass, 35.5. Its atomic number is 17. Its number of protons is 17. Its number of neutrons. So if I round this, it rounds to 36. 36 minus 17. 36. Here, let's just do it on the calculator so we can show you. 36 minus 17 equals 19. So we have 19 neutrons. Electrons, 17. Unless they tell me otherwise, I have to assume this is a neutrally charged atom. So no, it is not an ion. I know it's an ion when it has a different number of electrons from the number of protons. 17, 17. Nope. 53, 53. Nope. It's 13, 10. Yep. 20, 20. Nope. All right. 29 protons. That's going to be the same as its atomic number. So I'm just going to write that. And the same as its number of electrons. I'm going to write that. And 29 is copper. So it has an atomic mass of 63.5. And it is copper. Oops, sorry about knocking the camera. And so if I round this to 64, 64 minus 29 would be 35. And this has a different number of neutrons. So this is, no, not an ion. It is an isotope. It is an isotope. The normal periodic table copper would have 35 neutrons. I know y'all need to work on that a bunch, so please do. An element that cannot conduct electricity, is dull, and is on the right side of the periodic table would be classified as a nonmetal. All the evidence is there. It is dull. It does not conduct electricity. They could have said it was brittle. They said it was found on the right side of the periodic table. Everything to the right of the staircase is a nonmetal. List the properties and locations of metals, nonmetals, and metalloids. Appearance. They are shiny. Metals are shiny. Nonmetals are dull. Metalloids can be either. State of matter. Metals are solids. Nonmetals are solids, liquids, or gases. And metalloids can be solids, liquid. Oh, wait a minute. There's no metalloids that are anything other than solid, is there? No, they're solids. Here I am staring at the periodic table. They're solids. Conductive. Yes. No. Possibly. Possibly. Does it react with acids? Yes. No. And metalloids, possibly. You're going to get a lot of possibly. Location on the periodic table, the left side of the periodic table. Left side is metals, right side is nonmetals. On the staircase. On the staircase. Metalloids. What type of ions? Cations, always. Anions. And again, this could be either. Okay, which of the following contains a metal? Sorry guys, I'm done after this afternoon. I'm exhausted. Which of the following contains a metal, nonmetal, and a metalloid? Okay, metal, nonmetal, metalloid. Yeah, A, right out of the gate. Silicon is on the line. Aluminum is a metal. And carbon is a nonmetal. Anything else? Lithium, silicon, and calcium. That's a metal, a metalloid, and metal, metalloid, metal. Metal, metal, nonmetal. Non-metal, non-metal, metalloid. So, A is the only answer. During the flame test, as the solution is heated, electrons move from the ground state. Remember, this is our atom. This is our electron. It moves from the ground state up to the excited state. As the electrons fall back down, they release energy in the form of light. I would also accept photon, which is a particle of light, right? That's Bohr. That's Bohr. Bohr is telling you that. I promise you, you're going to see that on some tests. I promise, you're going to see that on some tests. No way around it. Multiple choice and explanation. Oh my gosh. Okay, given the orbital diagram. What's the identity of element A? Let's see. 3 electrons, 4, 5, 6, 7. If it has 7 electrons, it must be nitrogen. Nitrogen. Nitrogen is in the nitrogen family. Group 15. How many valence electrons does nitrogen have? It has 5. Is it a metal or a non-metal? It is a non. B. 2, 2, 4, 6, 8, 10. Now, this could be an ion. All ions assume the electron config or orbital diagram of a noble gas. Anything where you see P6, 2P6, that would be neon. So I'm going to say it's neon, but let's think about what happens to fluorine if it becomes an ion. It gains an electron, and guess what its electron config is? Just like this. So this could be fluorine 1 minus, or just fluorine minus, as we like to say. We don't write ones. So that could be that. But we're going to say it's neon. It's a noble gas. It's in family 18. Valence electrons, it has 8, and it is a non-metal. C. 2, 4, 6, 8, 10, 12. It has 12 electrons, therefore it is magnesium. Magnesium, sorry, I'm so tired. Magnesium is in alkali earth metals. Alkali earth metals have 2 valence electrons, and they are metal. Metal! Okay, D. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. It has 16 electrons, therefore it is sulfur. Sulfur is in the oxygen group or chalogen group. You can call it chalogen, oxygen, I don't care. Chalogens, which is family 16. And family 16 has 6 valence electrons, and they are non-metals. Non-metal. I'll just spell it out. And that is how we read orbital configurations, diagrams. Oh my goodness. Identify the elements with the following noble gas configurations. Now, I told you one way you could do that. You could look at argon, see that it has 18 electrons, go 18, 19, 20, 30, 32, and go to what has 32 and go, okay, it is germanium. Or you can just go to 4p2, germanium. Germanium. Again, helium has 2, 2, 4, plus 4 is 8. I could just go to oxygen. And it is it is 2p4. 2p4. 2p, 1, 2, 3, 4, oxygen. Oxygen. What is the correct electron config for bromine? Oh my goodness. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 3d10, 4p5. I think that's it. Bromine, right? Bromine. 4p1, 2, 3, 4, 5. Yep. Now you got to have an off bow to do that. You should be able to by now write your own off bow. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 3, 4, 5, 6. 4, 5, 6. S, 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 P, 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 D, 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 F, F, F. So like that, like that, like that, like that, like that. And that's all I needed to do bromine. Manganese, that has 12 electrons. So 2, 4, plus 6 is 10, 3s. So 1s2, 2s2, 2p6, 3s2, 12. Yep. 3s2. Oh, that's magnesium. What am I doing? That said manganese. Oh! We got to go to 25. Okay. 3s2, 3p6, 4s2. That's 2, 4. Plus 6 is 10. 11, 12, 18, 19, 20. We got to go to 25, so we need 3d5. 3d5. Now, I hate to show you this, but this first row of transition metals is actually 3, that's 4, that's 5, that's 6. So this is 3d, 1, 2, 3, 4, 5, manganese. What is the correct noble gas notation for calcium? Oh, too easy. So we go to calcium. We go backwards up the periodic table to find out what our first noble gas is. It is argon. And then it is 4s2. That is calcium. 4s1s2. Fluorine. Again, we go backwards. Fluorine, backwards to helium. And then after helium, which only gets rid of 1s2, we have to do 2s2, 3s2. No, sorry, 2s2. Oh my God, I'm so messing up. 2s2, 2p6, 3s2, 3. What am I doing here? God. Ugh. Fluorine, 2p6. That's right? 2 plus 4, 10. 6, 4. What am I? Oh my God. Guys, it has been a long day. Okay. Okay, so I'm going to stop the video and take a drink here and splash water on my face and try and wake up so that I don't make stupid mistakes the rest of this review. So I'll be back.